Here the problem is you should calculate weight of carbon dioxide formed during a chemical reaction. The problem is in the first condition 3 grams of carbon reacting with 8 grams of oxygen, they will form 11 grams of carbon dioxide. Then in the second condition, the same amount of 3 grams of carbon reacting with 50 grams of oxygen, then how much mass of carbon dioxide will be formed? Then after your answer going to be justify which law of chemical combinations. You have to tell that one also. Now going to the calculation part. See, carbon reacting with oxygen gas, then they will form carbon dioxide. In the first condition, 3 grams of carbon reacting with 8 grams of oxygen, they will form 11 grams of carbon dioxide. Here from reactant side it is 11 grams and the product side also 11 grams. So here that means by seeing this answer you can directly tell this condition is represents about law of conservation of mass. Law of conservation of mass is nothing but how much mass is going to be reacting in that chemical reaction. During that chemical reaction, that much mass will going to be generated. That is nothing but law of conservation of mass. This is the first condition. Then coming to the second condition, 3 grams of carbon reacting with 50 grams of oxygen, then how much mass will be generated? See, here 3 grams, here also 3 grams. So that the 3 grams in the previous condition reacting with 8 grams. That means here also the 3 grams of carbon reacting with 8 grams of oxygen. So here 42 grams of oxygen will be the leftover one. It will not going to be reacting with this 3 grams of carbon. So here also 11 grams of carbon dioxide will be formed. See, by seeing this reaction, you can conclude the second condition obeys about law of constant proportion in a chemical reaction for the formation of a compound. First condition, law of conservation of mass. Second condition, law of constant proportions. This is about this problem. Here the problem is you have to calculate percentage composition of a compound by its weight. The compound's total weight is the 0.24 grams. That given compound's sample containing 2 atoms or elements, those are nothing but here oxygen and boron. The boron atoms or elements weight is the 0.96 grams, and another atom or element is the oxygen, that one's weight is the 0.144 grams. So you should calculate this particular weight's percentage composition. That percentage composition formula is the mass of element or atom upon mass of compound, or total mass of compound into 100. This is the formula for the percentage composition. So now you can substitute these values. First of all, I am going to calculate about a percentage composition for the boron. So for boron, percentage composition is equal to, what is the mass of boron atom or element is here 0.096 divided by, what is the complete compound's mass, 0.24 grams into 100. So by multiplying with this 100, 0.096 will become 9.6 divided by 0.24. Then you can multiply numerator and denominator with 100. So you will get 960 divided by 24. Here see, 24 fours are 96, then 0. That means 40% of boron is present in the 0.24 grams of sample containing compound. So, then coming to the calculation of oxygen's percentage, oxygen weight is 1.44 grams upon complete compound weight is 24 into 100. Then this 1.44 will become 14.4 upon 0.24. Then again you can do multiplication numerator and denominator with 100. Then you will get 1440 upon 24. See, 24 6 ja 144, then 0. See, this is the 60% of oxygen present in the 0.24 grams of compound. Actually, by calculating first elements percentage weight, then after you can directly calculate second elements percentage weight. How can you calculate that? See, the complete compound's weight is equal to 100 percentage. If 100%, then 100 minus 40 will gives you 60% of second elements mass percentage weight. Okay, see here this is the explanation for this problem. Here the problem is calculate the number of aluminum ions present in the 0.051 grams of aluminum oxide. What is the aluminum oxide's formula? That is Al2O3. And what is the atomic mass for aluminum? That is 27, and atomic mass for oxygen is 16. Remember one thing, this 27 atomic mass is applicable for aluminum atom as well as aluminum ions. Remember this one. Then you should calculate about molecular mass of aluminum oxide. 2Al plus 3 oxygen atoms is equal to 2 into aluminum atoms atomic mass plus 3 into oxygen atoms atomic mass. So, 2 into 27 will gives you 54 plus 16 3s are 48. This will gives you 102 grams. Nothing but Al2O3 molecular mass is 102 grams. Now coming to the problem. See, what is the number of particles present in 0.051 grams of aluminum oxide? So first of all, you should need to know about this 102 grams of aluminum oxide is equal to the 1 mole. Nothing but 1 mole of 102 grams of aluminum oxide is equal to the 6.022 into 10 power 23 particles or molecules or ions. Then 0.051 grams of Al2O3 having how many number of aluminum ions? You should calculate it. Same old story here also you can repeat cross multiplication. Then you will get 6.022 into 10 power 23 into 0.051 grams divided by 102 grams. So, in this part, this one and this one, if you calculate or if you simplify these three numbers, you will get 0.03011 into 10 power 23 particles. To simplify this one, you can multiply 3 tens from this 10 power 23 to the 0.003. So, you will get 3.011 into 10 power 20. Is this your answer? No, it's not your answer, because here one aluminum oxide molecule having 2 number of aluminum ions. So you should multiply this number with 2. So into 2 you can do, then 2 3s are 6, 2 zeros are 0, 2 1s are 2, 2 1s are 2 into 10 power 20 molecules. This is your answer. Nothing but 102 grams of aluminum oxide having 6.022 into 10 power 23 molecules are aluminum ions. So 0.051 grams of aluminum oxide having 6.022 into 10 power 20 number of aluminum ions. This is your answer for this question. Here is the problem. You should calculate about number of molecules present in a 16 grams of solid sulfur. That molecules are in the form of S8 form. To this one, first of all, you should need to know about what is the atomic mass for a single sulfur atom. One sulfur atom atomic mass is equal to 32 grams. You already know. So here this solid sulfur is in the form of S8 form. So that 8 sulfur atoms mass is equal to how much? Here see 32 into 8 you can do. So you will get 8 2s are 16, 1, 8 3s are 24 plus 1, 25. So 256 grams is the molecular mass for the S8 molecule. Now coming to the point. Here he is asking number of S8 particles present in the 16 grams of solid sulfur. Now you can take this one. 256 grams of S8 molecules are nothing but 1 mole. That 1 mole of 256 grams of S8 molecules is equal to 6.022 into 10 power 23 molecules. So then what is the molecules number present in the 16 grams of solid sulfur? So here also same as usual in previous cases. So here you can do cross multiplication, then you will get your answer. 6.022 into 10 power 23 into this 16 comes to here, then 256. You can choose this 16th table. 16 1 ja 16, 16 16 ja 256. Then after you can choose 8th table. 8 2s are 16. Then you can put a point. 8 7 ja 56. 4 is the remainder. Then that will become 42. 8 5s are 40. Then 2 is the remainder 22. 8 2s are 16. Then 4 is the remainder. Then 8 5s are 40. Now coming to, you can do this second table. 2 1s are 2. Point. 2 3s are 6. 2 7s are 14. 2 6s are 12. 2 2s are 4. 2 5s are 10. You can leave these two decimals for simplification. So for 0.376 into 10 power 23. From this 23, multiply with 110 to the 0.376. So you will get the answer 3.76 into 10 power 22 molecules are present in the 16 grams of sulfur molecules or solid sulfur. This is your answer for this question. Thanks for watching.